A ratio distribution is a probability distribution constructed as the distribution of the ratio of random variables having two other known distributions. Given two random variables x and y, the distribution of the random variable z that is formed as the ratio is a ratio distribution. The Cauchy distribution is an example of a ratio distribution. The random variable associated with this distribution comes about as the ratio of two Gaussian distributed variables with zero mean. Thus the Cauchy distribution is also called the normal ratio distribution. A number of researchers have considered more general ratio distributions. Two distributions often used in test statistics, the t-distribution and the f-distribution, are also ratio distributions. The t-distributed random variable is the ratio of a Gaussian random variable divided by an independent chi-distributed random variable, while the f-distributed random variable is the ratio of two independent chi-squared distributed random variables. Often the ratio distributions are heavy-tailed, and it may be difficult to work with such distributions and develop an associated statistical test. A method based on the median has been suggested as a workaround. Algebra of random variables. The ratio is one type of algebra for random variables, related to the ratio distribution of the product distribution, sum distribution and difference distribution. More generally, one may talk of combinations of sums, differences, products and ratios. Many of these distributions are described in Melvin D. Springer's book from 1979, The Algebra of Random Variables. The algebraic rules known with ordinary numbers do not apply for the algebra of random variables. For example, if a product is C equals AB and a ratio is D equals C, it does not necessarily mean that the distributions of D and B are the same. Indeed, a peculiar effect is seen for the Cauchy distribution. The product and the ratio of two independent Cauchy distributions will give the same distribution. This becomes evident when regarding the Cauchy distribution as itself a ratio distribution of two Gaussian distributions. Consider two Cauchy random variables, and each constructed from two Gaussian distributions, and then where the first term is the ratio of two Cauchy distributions while the last term is the product of two such distributions. Derivation, a way of deriving the ratio distribution of z from the joint distribution of the two other random variables, x and y, is by integration of the following form. This is not always straightforward. The Mellin transform has also been suggested for derivation of ratio distributions. Gaussian ratio distribution, when x and y are independent and have a Gaussian distribution with zero mean, the form of their ratio distribution is fairly simple. It is a Cauchy distribution. However, when the two distributions have non-zero means, then the form for the distribution of the ratio is much more complicated. In 1969, David Inkley found a form for this distribution. In the absence of correlation equals zero, the probability density function of the two normal variable x equals n, I1/4 x, I florin x2, and y equals n, I1/4 y, I florin y2, ratio z equals xy is given by the following expression, where and is the cumulative distribution function of the normal distribution. The above expression becomes even more complicated if the variables x and y are correlated. It can also be shown that p, z, is a standard Cauchy distribution if I1/4 x equals I1/4 y equals 0, and I florin x equals I florin y equals 1. In such case b, z, equals 0, and if, or the more general Cauchy distribution is obtained. Whereas the correlation coefficient between x and y and the complex distribution has also been expressed with Cummer's confluent hypergeometric function or the Hermite function. Equals A transformation to Gaussianity equals, A transformation has been suggested so that, under certain assumptions, the transformed variable t would approximately have a standard Gaussian distribution. The transformation has been called the Guerrier-Hinckley transformation, and the approximation is good if y is unlikely to assume negative values. Uniform ratio distribution, with two independent random variables following a uniform distribution, for example. The ratio distribution becomes Cauchy ratio distribution, if two independent random variables, x and y each follow a Cauchy distribution with median equal to 0 and shape factor, then the ratio distribution for the random variable is. This distribution does not depend on and the result stated by Springer is not correct. The ratio distribution is similar to but not the same as the product distribution of the random variable. More generally, if two independent random variables x and y each follow a Cauchy distribution with median equal to 0 and shape factor and respectively, then, 1. The ratio distribution for the random variable is 2. The product distribution for the random variable is. The result for the ratio distribution can be obtained from the product distribution by replacing with ratio of standard normal to standard uniform. If x has a standard normal distribution and y has a standard uniform distribution, then z equals x/y has a distribution known as the slash distribution, with probability density function, where I, z, is the probability density function of the standard normal distribution. Other ratio distributions, let x be a normal, 0, 1, distribution, y and z be a chi-squared distributions with m and n degrees of freedom respectively. Then, where Tm is student's t-distribution, is the f distribution and is the beta distribution. Ratio distributions in multivariate analysis. Ratio distributions also appear in multivariate analysis. If the random matrices x and y follow a Richat distribution, then the ratio of the determinants is proportional to the product of independent f random variables. In the case where x and y are from independent standardized Richat distributions, then the ratio has a Wilks lambda distribution. See also, inverse distribution, product distribution, ratio estimator, slash distribution. References. External links, ratio distribution at MathWorld, normal ratio distribution at MathWorld, ratio distributions at MathPages.